Hi everyone, today we'll discuss the very fundamental topic of electrostatic, that is called electric field and properties of the electric field lines. Talking about this electric field, the definition is very clear. The region surrounding a source charge where the influence of the charge can be realized by a unit positive test charge is called electric field intensity or electric field strength of a source charge. One more time I want to repeat the statement. The region surrounding a source charge where the influence of the source charge can be realized by a unit positive test charge is called electric field strength or electric field intensity of that source charge. Let's consider a charge Q which is treated as what? A source charge. This is charge Q which is treated as a source charge. And what I will do, I will bring a unit positive test charge, and whatever the influence of this test charge field, that can be treated as the electric field strength or electric field intensity of this source charge. Here the question will arise that why a unit positive test charge? This is a test charge. And what is its magnitude? Magnitude is a unity. You can say 1. Now the question arises why it is a unit positive test charge? Because if I consider this charge have some larger magnitude, then this test charge cannot give the exact field strength of this source charge. If I consider this is bigger, then this charge is always considered to be what? Smaller in front of this charge. So it is a unit positive test charge, so that very negligible magnitudes or magnitude as a unity, so that this test charge can give you the proper information about this source charge. This is very fundamental things. And how the mathematical definition says? Mathematical definition says electric field strength or electric field intensity E equals to force experienced by this unit positive test charge upon test charge. One more time I want to repeat. Electric field intensity or electric field strength is defined as the force experienced per unit positive test charge. The force experienced by the unit positive test charge upon the test charge. Electric field intensity, it is a vector quantity, that's why I'll put an arrow, and force is also a vector quantity. So electric field intensity mathematically can be defined as force experienced by the test charge upon unit positive test charge, and it is a vector quantity, that's why I put an arrow. Now the question will arise, what is the direction of the electric field intensity? The direction is along the direction of the force, or we can say in which direction this test charge is moving, that is the direction of electric field intensity. If I will go for the magnitude part, if I will go for the unit part, that electric field intensity, that is force experienced for unit test charge, Newton, and what is that? Unit is Coulomb. So I can say Newton Coulomb inverse. This is the unit, and dimension everybody know, that is Newton is force, that is m1, mass into acceleration, and Coulomb can be written as AT because Q equals to IT, current is ampere and T is T, I can write like this. So this is what? m1 L1 T minus 3 A minus 1. This is exactly the dimension formula of electric field intensity. And what is the direction of electric field intensity? It is the direction along the direction of the force, or in which direction the test charge is moving, that is the direction of electric field intensity. I hope the scenario is clear. I want to repeat it again. the region surrounding the source charge, where the influence of the source charge can be realized by test charge, is called electric field intensity or electric field strength of the source charge. And electric field mathematically can be defined as force experienced by this test charge upon unit positive test charge. Magnitude, in term of unit, it is Newton per Coulomb, and in form of dimensions, simply force dimension, charge dimension I am putting and getting the dimension formula, and it is a vector quantity. Now come to the property of electric field lines. What are the properties of electric field lines? What is the first property of electric field lines? Says electric field lines are nothing but the imaginary lines. This is a charge, source charge. This is a test charge. This charge is feeling something about this charge. This charge have some influence. This is a source charge, and source charge having some impact on this charge, and whatever the influence this charge realize, that can be treated as the electric field of this charge. But in between these two charges, the medium is air. We don't know what is the impact is happening. Everything is invisible here. So what do we consider? We consider some imaginary lines. So what I'll say, electric field lines are the imaginary lines. Imaginary lines which describe the electric field. Electric field lines are the imaginary lines which describes the electric field intensity. So these are nothing but the imaginary lines what we draw. Second most important thing is what? Whatever the imaginary lines we draw, this line is combination of so many points. So what I'll say, these imaginary lines are the combination of so many points. So the tangents drawn at any point will give the electric field intensity direction at that point. First point, electric field lines are nothing but the imaginary lines to describe the electric field intensity or electric field. Second, any line is combination of so many locus of points, we can say, and the tangent drawn at any point give the direction of electric field at that point. So this is the second point is what? Tangent. And tangent drawn at any point give the direction of electric field intensity at that point. Third most important point, two field lines never intersect. Suppose this is one field line and this is one field line. This is the common point. At this point, what will happen? I will draw tangents. The most important line is here, two field lines. This is one field lines. This is another field lines. The two field lines never intersect because at the point of intersection, there will be two possible tangents can be drawn. It means tangents are nothing but the direction of the electric field. So two direction at one point, which is practically not possible. That's why two field lines never ever intersect. And fourth most important point, for positive charge, the field lines are radially outward. It will be like this. For positive charge, the field lines are radially outward. And for negative charge, the field lines are radially inwards. This is very important point that you have to be in your checklist. For negative charge, the field lines what? Radially inward. I want to repeat it again. The tangents drawn at any point, on the field lines give the direction of electric field at that point. Two field lines never intersect. At the point of intersection, there will be two direction of electric field, which is practically not possible. For positive charge, the field lines are radially outward. For negative charge, the field lines are radially inward. This is the scenario that you will have to be in your mind. And electric field lines are the imaginary lines to describe the electric field. This is very important point that to be had. And fifth important point, you can say the electric field lines are discontinuous in nature. Electric field lines are discontinuous in nature. Why it is discontinuous? Because when you look at a magnet, this is north pole, this is south pole. What will happen? It starts from the north pole and ends at the south pole. The magnetic field lines start at the north pole, ends at the south pole, and inside it is south to north. Inside it, what it is? It is south to north. But if I consider two conductors, this is two conductors, this is positive, this is negative, what will happen? Positive, it radially outward, and negative, it start from the positive, ends at the negative. But inside the conductor there will be no electric field lines. So you can say in space the field lines are continuous, but in overall I can say the electric field lines are discontinuous in nature. Electric field lines what? Discontinuous in nature. Why? Because electric field lines never form the closed loops. Electric field lines never ever form the closed loops. Overall it is discontinuous in nature, but if you consider only space part, it is a continuous in nature. One can feel this. These are the practically you can realize these things. So these are the major points what I will remember. The tangent drawn at any point on electric field lines give the direction of electric field line at that point. Second, two field lines never intersect. If they intersect at the point of intersection, there will be two direction of electric field, which is not possible. Fourth, for positive charge, the field lines is radially outward. For negative charge, field lines are radially inward. Electric field lines are discontinuous in nature, but in space you can say this is a continuous in nature, and electric field lines never form a closed loop. This is exactly what you say, this is a closed loop, but here the field is 0. For a conductor, this field is 0. So electric field lines never form a closed loop. These are the important things. Please add in your checklist for student perspectives. I hope this scenario is pretty clear to everyone. Thank you everyone for your watching. Thank you.